So in exercise D, it's just like using all the knowledge we learned before to do the application question. So just have a think again what we have done yesterday. Yesterday we did two things basically. The first thing is giving you the mean, giving you the standard deviation. How do you find the probability? Okay, answer is using calculator, but that's in menu 552. The second thing is giving you the mean, giving you the standard deviation, giving you the area according to a point, and ask you to find what point can give you that area. Okay, so using calculator again, but this is like advanced using of calculator because it can only work to the left of that point. Okay, the area you need to enter must be to the left of that point, not to the right. Okay, if it's to the right, it's wrong. Okay, you get a wrong answer. And then we just practice a lot of questions, A, B, C, D here. And then for D, let's have a look at this example. Stake cells, garden stakes that are advised as being 1 meter long. So the stakes are advertised as 1 meter long. So you're supposed to get something about 1 meter. And you know that's not going to be exactly 1 meter. So the length of the stakes are normally distributed. Okay, normally distributed. So with a mean of 1.015 meters and a standard deviation of 0.01 meters. Okay, so let's say let the length of stakes be x meters, and x will be normally distributed by 1.015, 0.01 squared. Okay, that's the normal distribution. So that's what has been given. Okay, what has been given. Give your answers correct to 4 decimal places. Okay, if a person buys 1 garden stake, what is the probability that's longer than 1.025? So is the probability of x greater than 1.025? So that's calculator question. Okay, after you have those 3 lines, that become a calculator question. So menu 552, I hope you can remember that. 1.025 to infinity. Infinity is control of the book. And then you have 1.015. The standard deviation is 0.01. Okay, 0.01. Okay, just check all the informations. Greater than that means that standard deviation is that greater than that is infinity for the upper bound. And that is the probability. Okay, 4 decimal places, 0.1587. I hope you have your calculator with you every day, and then you can really type that by yourself. Just do not look at what I'm typing. Sometimes, okay, one thing is you need to practice your speed of typing all those things. Second, like you need to make sure like the accuracy, okay? You actually exactly know what to do with it. Watching me of doing questions is not helpful. Okay, shorter than 1.01 meters. Okay, like this question are like really easy. Okay, for what we do is really easy here. So let's just do it together. Shorter than 1.01. So it's x less than 1.01. Okay, x less than 1.01. So probability x less than 1.01 is not that. Okay, I will keep that minus infinity 1.01. Wait, minus infinity. This comma 1.01. And the mean is 1.015 and standard deviation is 0.01. So we have that 0.3085. Okay, and then between that two values, so probability of 1.025 between that. Okay, 1.025 to 1.04. 1.025, 1.04, 1.025, 0.01. Okay, 0.4332. 0.4332. Okay. That's the first three basic ones, and then the next one says a person can get their money back if the stake is less than 1 meter long. Okay, tell me a reason why they set the mean to be 1.025. Why do you think it sets that to 1.025? What will happen? Like if it's less than 1 meters, I will refund the person. What's the probability if I set the mean at 1 exactly? Okay, if I set the mean at 1 exactly, what's the chance you will refund? You refund the person. 0.5. Okay, if 1 is the mean, that's exactly sit in the middle. You have half of the chance that to refund people, but that's what you don't want. Okay, that's what you don't want. So that's why you slightly set that a little bit higher, than to reduce the probability to refund people. Okay, so that's why they set that higher, because like you will see a similar question later. Okay, similar question later. Can get money back. Okay, what's the probability that person is eligible to get money back deal? So that's the probability x less than 1 meters deal. Okay, less than 1 meters deal. So we have, I'll just copy that down. And I will change this number to 1. Okay, 1, negative infinity to 1. Negative infinity to 1. Okay, and then everything is the same. This only give you a anything wrong? No? Only give you a probability 0.0 something. Okay, it's a really small probability if you set that like high enough. So 0.0668. What's probably the person who buys one is eligible for the money back deal? Okay. What is the number of refunds the store would expect if 500 stakes were sold? What do you think you would do for that? Okay, times by 500. Most of you will think about times that probably by 500. But why? What's the, if I ask you to reason why, or give you any formula you think you should apply, what do you think the formula will be? Okay, let's give you a hint. Let n be the number of stake being refunded. Okay, let n be the number of stakes being refunded. Okay, I don't know how many. That's a random variable as well. It doesn't, really not sure. I can get 1 refund. I have 0. I can have 500. What distribution do you think n follows? Binomial. That's correct. You only have 2 distribution. That's 500 and get a successful rate of 0.0668, like dot 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 dot, like this more. Okay, at the back. So we are looking for the expected value of n. That is just n times p, and that's why it's 500 times 0.0668, and that equals 2. Okay, do not just use 0.0668 using the full values here. So you directly use that answer to times by 500. Use exact. Okay, use exact. That's 33.4, so approximately 33. You can't have equal sign. Approximately equals to 33. Alright. So, yes, it is 500 times that, but why? Okay, that's plus why. So, there's a lot of questions in VCA, which is a combination of binomial distribution and normal distribution. Okay, the question will exactly be asking this way. There will be harder questions than this, but it has been done by binomial. I'll show you, like we'll do some practice when we finish the course, and I will tell you which year is that. I just remember, I think it's the year before I did it, 2010 or 2011, there were probability questions, which is quite good. I'll find that out and let you do that. So, next one. If a person buys 3 steaks, what is the probability that they are not eligible for a refund on any of that? So 3 of them not, like, again, this is still a binomial case, which you want n equals to 0. You want x equals to 0 and the total number equals to 3. Okay, so, but like I can do 1 minus 0.0668 to the cube. You cube it. Okay, you cube it. So 1 minus that. Okay, and then you cube that. That's 0.8127. 0.8127. Okay, like eligible to refund 0.0668. So not eligible is 0.93319. And then you cube that because there's 3 steaks. Okay, 0.8127. Okay, everyone, that's a warm-up session. Are you feeling ready? Okay, warm up already? Okay, next question is interesting. Okay, next question is interesting. There's only just one question. Okay, just one question here. The volume of soft drinks in 1 liter bottle is normally distributed. Okay? The bottle you buy, the soft drinks, is 1 liter bottle. But it can be less than or more than 1 liter. And the soft drink company needs to put in a filling machine, and they don't want to put too much or too little. Okay, too much costs more. Too little, they need to refund, say they need to refund or something like that. Okay, see here. However, they know they will be fined if more than 2% of the bottle are more than 2 liters under the volume. Okay, so tell me what like 2 liters under the volume, what the value should be. Like what I have 1 liter and 2 milliliters under the volume. What's that? 998. Okay, let's just draw a distribution. So I don't quite sure about what is the mean, okay, because it's asking for us for the mean. Okay, so if more than the bottle are, like if 2% of the bottle, more than 2% of the bottle are more than 2 milliliters, so you will get fined. So let's say exactly 2%. This place should be 998. Is that all right? Like less than that, okay? 998 less than that. That should be 2%. You can't have more than 2%. Let's say the extreme case exactly equals to 2%. That's where is the area I'm talking about. Under than that. Okay. So the next thing we talk about is like the standard deviation is given. The standard deviation is 2.5. Okay, let X be the volume of the soft drink, and X will be normally distributed. Mean is not given, but standard deviation is given, 2.5 squared. Alright, let's say exactly I know what is the 998? 998 to the left of the 98 is 2%. Okay, let's think about that. That's 2%. Okay, tell me something. Do you think the higher the mean is better or the lower the mean is better? Well, like, do you think if I set mean as 998 is working? If my mean is 998, is that working? No, it's 50% on the left. Okay, so which means I should set a higher volume as my mean. Does that make sense? Like, if my mean is higher, I have a lower chance I can have less, right? Like that's exactly what I'm talking about here. Why they set the mean as 1.025, not as 1 meters exactly? Because if they set 1 exactly, there's 50% of the chance you need to refund back, right? This is the same case. If you have, like, let's say this, you know, after 3 standard deviation, there's almost no area under the curve, right? After 3 standard deviation, 99.7 is within 3 standard deviation. The rest is just, in total, is 0.3%. So very little. So let's have a think. If you set your volume as 2 liter of mean, okay, 2 liter as the mean, and the standard deviation is 2.5. Do you think you get below 998? It's very, very hard to get below 998 because, okay, 2 liters here, 3 standard deviation on each side, cover 99%. So 998 is very far away on the left hand side. So it's very unlikely to have that value. So it's definitely below 2%. But if you set the 2 liters, it costs more. Okay, all the bottles is around 2 liters, it costs more. That's what you want to avoid as well. So the ideal point is I exactly have 2 liters here. And I want to find, okay, what mean I should have, can give that exactly 2%. Okay? So the problem for this question is, I don't know the mean, okay? I can't put in the inverse. Like, well, I don't really need the inverse. I already have that. So I need to find a way to calculate that. There's 2 ways of doing that. Okay, there's 2 ways of doing that. Which way you want to go first? Let's go the calculator way. The calculator way is not safe, but it can work. Okay, so what I want to do here is, well, I know most of the things already. I don't know the mean, I know the standard deviation, I know the area, and I know the value give that area. The only thing I don't know is the mean. I can solve for it. Okay, so what I'll do is menu 3.1. I want to solve for something. What I want to solve, menu 5.5.2. Okay, into this one. That 998. And I don't know what's that. I put X in. The standard deviation is 2.5? Okay, standard deviation is 2.5. Okay, I put all the information I have in first. It's okay, it's a two-field argument. And I make that equals to 0.02. That's the 2%. And also comma X. Hopefully that will work. Sometimes it doesn't work. Okay. If you come, oh, it's working. Okay, I'll just make it higher. I'll just make it higher. Okay. Can you see it? Can you see it now? Okay. So what you're trying to do is say negative infinity to 998 with mu unknown and standard deviation unknown with 0.02 case. And I'm looking for X. Okay, that area gives me is 0.02 and I'm looking for X. This is like, there's 4 things, okay, there's 4 things. Mean, standard deviation, area, and the value gives that area. Okay, 4 things. If you miss one of that, okay, any one of that, I can use calculator to directly work out that. If you miss 2 of that, there's no way of doing it, okay, like, you can't miss 2, okay, you can't miss 2. If you miss 1 from that 4 thing, yes, you can directly use calculator to do it. This is very important, and this can save you a lot of time, okay? If you not pay attention to that, you just don't know what to do. Okay, so calculator, the calculator, sometimes it doesn't work. I'll show you the other way, like the hand approach way, how to do it, but like, better like you know this, okay? When mu is unknown, yes, calculator will directly give you the value. Works 99.9% of the time. But when you're looking for standard deviation, there's a trick there. Like I'll show you that later. Like when standard deviation is not given. Let's say give you the mean is 1003 now. What is the standard deviation? You need to do something else. I'll talk about that later. But like make sure you understand this one now. Okay, and I'll show you the hand approach. That's an X normal distribution. Let's have a think about the Z normal distribution. Okay, think of Z normal distribution. Everything will relate back to Z normal. You must know this method, okay? This is an easy question, that's why I can solve it by CAS. But like later I will have a harder one, you can't solve by CAS. So you must know both methods. Okay, both method is important. So on Z normal distribution, I can map this 998 back to Z graph. So what that will become is 998 minus mu divided by 2.5. Okay, that's how we plot that back to a Z normal curve. Okay, those two shading area must be the same. 2%. Those two shading area must be the same. Right? Like, all to the left of that point, the area should be the same. Like, that's what we talk about for the standard normal distribution. Standardized. Okay, how we talk about standardized. But, what you know is, this is a Z normal distribution, right? A Z normal distribution. Z normal distribution is with mu 0 and standard deviation 1. Then I can use inverse normal. Menu 553, go inverse normal. The area I want is 0.02. Those two just like correct values. Okay, 0 and 1. Standardized normal. So on the standard, menu 553, area 0.02. Okay, that value minus 2.0537. Okay, this value is equivalent to minus 2.05375. Let's say. Keep going. All right, so ignore what's that. If on a Z normal you want 2% on the left, what you will have, it must be negative 2.05. It can't be any other values. On a Z normal, I want that is 2%. It must be this value here. So the conclusion I can make here is 998 minus mu over 2.5 is equals to minus that 2.05375. They must be equivalent because that is the value you plot to Z normal. And then you know that if you want 2%, that must be negative 2.05. So therefore they must be equivalent. If they're equivalent, I can solve for mu here. Okay, I can solve for mu here. So is times that by 2.5. And then you use 998 minus that. So that gives you this value. That's the same as what we solved when we use calculator. 1003.134. Okay, it's exactly the same value. We just solve for it. Okay, just solve for. You know how to solve for mu. That's 998 minus mu equals to minus 2.505 times 2.5, and then mu equals to 998. Subtract this. Okay, mu get 1003.13 something. Okay, I don't care. Okay, so that's method 2. That's method 2. So method 1 is by CAS. Okay, solve. Okay, again, do not write like that. I want to show you what we have done. So do not write this on your paper. Okay, if it's by calculator, just directly write the answer. Okay, if it's calculator, directly write the answer. Do not show the calculator syntax. Solve for what? Solve for normal CD NORM CDF with the area negative infinity to 998 and x and 2.5, and that equals to what? 0.02 comma x. Okay, you have solved that x equals to 1003.134 1, 3, 4, 3, 7. Okay, two methods. One is plot back into Z normal, and one is solving by calculators. But have a read of the question. Read the question. The question says, what should be the target, the mean of the distribution? Answer in the nearest millimeter. what the answer should be? What's the nearest millimeter? Well, it's let me just ask in this way. Is that 103 or 104? Why 103? Okay, it's not like looking for 5 and round up or round down, because you need to think about that exactly give you 2%. If that decreased, it's more than 2%. Okay, that will be more than 2%. That's the minimum value you can have. You can't go below than that. If you go below than that, this area will become more than 2%. Okay, so you must round up. This like is ignore the rule of the number rounding up or rounding down. What you're looking for is the actual meaning of the question. Okay, it's the actual meaning of the question. Like there's some question like that. Okay, it's really tricky. You need to think about the meaning. That you must remember that's the minimum requirement you are looking for. Okay, so mu must be 1004 round up. Okay, because 103 will give you area more than 2%. Because the higher the mean, the lower that area, okay, the lower the tail. So now your minimum mean is that you need to go up a little bit. All right. Why I still have 2 more pages? Okay, let's have a think about that question. Let's assume we change the question a little bit. Just a little bit. Is we don't know the standard deviation, but we know the mu. And exactly same condition applies. Okay? Exactly same thing applies. Same area, same thing. Just instead we know that our mu, so x is normally distributed by mu is 1004 and standard deviation unknown. Okay? I still want the probability x less than 998 to be equals to 0.02. And we're looking for standard deviation. I can just change a tiny bit. Okay, for this method, for this z-plot method, I will still have 998 minus 1004 divided by standard deviation. That gives you minus 205 something, and then solve for standard deviation, right? We still can do the z-plot thing. Plot that to z, and then you know that what give you 2% is negative 2.05. Give you that. Okay, that's one method. If you use the calculator method, menu 3 1 to solve, menu 553 of that, 552 for that, negative infinity to 998 with mu given 104, but this is x. It's okay, just click alright. So it's too few arguments, that's fine. That equals to 0.02 and comma x. Let's see. Okay, what happens? Magic happens, it doesn't work. Only change a little bit, doesn't work. That's what I said for the tricky thing of standard deviation. Alright, don't worry. Hopefully I can fix this. Okay. That's the difference between mu and standard deviation. Okay, standard deviation is just tricky. So go control and that give a bar. I want to restrict something. Let's restrict that x greater than 0. Try again. Worked. Okay, I don't know why. Okay, don't ask me why. I just figured this out. I just try, and then I figured this out. I don't know why I figured this out. I figured this out when I was in year 12. Because I said, why mu's working, but standard deviation not working? And then I tried a couple of things, and I find this worked. And I still can't answer like why it's like that. Maybe standard deviation is much trickier compared to the mu. Okay, mu will be unique and standard deviation will not. So what you have is 2.92 something. Okay, that should be your answer. Okay, so difference between mu and standard deviation. Standard deviation needs to restrict it. Okay, needs to restrict the domain. What's the value before? 1003.134? Is that the answer? Oh no. What's the exact answer? 134? 134. Let's keep like that. Okay, that's approximately 2.5. See, we get the correct answer. That's approximately 2.5. I've just used a wrong number, like 1004. So that should give you 2.5. Like if you give more decimals at the back, you'll be very close to 2.5. Okay? Okay, so that's... Okay, the one who missed today's lesson needs to really know this. Tell them, okay? Tell them. So for looking, if you use this plot, if you just use the Z plot method, go standardize the Z, that's no problem. Okay, you can do it as normal. Like, it doesn't matter. Like, but for calculators, standard deviation needs to restrict the domain and then work it out. Alright. Skip that one. Chapter exercise 11. Okay, limits of acceptability. Wait, just wait a second. I will save this one first.